Hi students, we continue about the 6.3. There's a ray diagram of lenses. So for this one, we need to know how to draw the ray diagram from the convex and also concave lens. Okay, let's see the diagram. Okay, so the first one is a formation of the image by the convex lens. We go to introduce the convex lens first. Okay, from here they show about the object. There's a O between the F and also the optical center. So this one is a optical center. So the F is here. So this one F stands for focal point. Okay, now your object is between these 2 points. So we can say the object distance now is less than F. So normally we want to get the image, at least you must got 2 lines. Okay, when the 2 lines they point together, means that overlap. When they just overlap, so that means we know that point, so we can draw the image. So actually 3 also can be joined together, because before that we learned about 3 rays, first, second and also third. So from here we just memorize 2, then we enough already. Okay, let's see the first one. We're using number 1 and number 3. That one is more easier to draw. The second ray will hard a little bit. So we try first ray first. Okay, from the object parallel, go to the center line. Okay, remember there is a whole straight line at the center. The curved one we don't want to touch. So when I touch about the curve, you still go in until the straight line. So this one straight line, we call it as a center line of the lenses. Okay, after parallel, we must go to find F, is it? Then we go to find the following F. Okay, so this one we call first ray. Okay, then this situation we find it actually you cannot touch at the lower part. So if they cannot touch the lower part, that means we need to extend. Okay, one more thing to tell you, this situation, this part, there's a virtual part. Okay, the lower part, this part we call it there's a real part. Okay, now we continue to draw first. Okay, because later we find it, this part we cannot join, we cannot get the image. So this part cannot get the image, they must go to the part 1. So we label this one part 1, this one part 2, part 3 and part 4. So that means part 3 is a real, part 4 also is a real. But this one situation we just using part 1 and part 3. So virtual image will happen at the part 1. Then the real image will happen at the part 3. So now we're going to continue to draw the third ray. Okay, third ray must be past the center from the object. So now you can see the blue and also the green line, sure they cannot touch because they keep open wider. So I still need to extend the green line, become longer to the part 1. Okay, I told you already the part 1 is a virtual part. So we're using dotted line. Okay, so finally they join already. Okay, when I just extend until overlap to each other, can you see this point? This one already is an image point. Okay, last one, we need to draw the image. Okay, remember when you draw the image, we every time to see the horizontal line. This one is a horizontal line. So that means I need to draw start from the horizontal line. Okay, from here you move up. Okay, so where you touch this here, so that means from the horizontal line, you draw the arrow up. The arrow must be exactly same like the object. Okay, you don't tell me your image different with the object. Normally there's the same pattern with the object. Maybe the size different, but the pattern all should be the same. Okay, now we draw the image. Remember, part 1 is a virtual, so everything must using dotted. Okay, now we go to draw from the horizontal line. Okay, then move up. So we find it. This one is my new image. So from here, we need to give the characteristic for this one situation. Okay, before we give the characteristic, we measure what is the object distance, what is the image distance. Okay, so this one we call it as a image distance. Okay, we label by V. Okay, where is the object distance? Object distance must start from the object, go to center. So this one we call it object distance. So from here we find it image distance longer than the object distance. Okay, this one is a distance comparison. Now we're going to see the image comparison. Okay, now you see the characteristic for the image. First one, virtual, because they happen at the part 1. Virtual means they cannot capture on the screen. Okay, for this one situation, we apply for the magnifying glass. Okay, magnifying glass, that means they can see the image. When I just using the paper to close, that means you cannot see the image. That one we call virtual image. Okay, number 2, you can see upright. Upright means the object head at the top, this one also at the top. So that means you see the pattern should be the same. That means the word do not inverted. That's a upright. Okay, last one is a magnify. So you see the image finally is a larger. So this one is the same as the function for magnifying glass. Okay, so the comparison for the distance, image distance is longer than the object distance. How we go to memorize? We're using the short form for characteristic, VUM. Okay, there's a virtual, upright, and also magnify. Okay, so this one is a first step. We're using the U less than F. Okay, first step, then we continue to the next one. The next one, the setup almost the same. Okay, exactly the convex lens. Okay, but now the object at the F, exactly on the point F. So we write U equal F. Okay, U equal F. I can tell you this one situation sure is a virtual. Okay, we just got 2 situations for convex lens. There's a virtual. One is just now, when your object is located. Okay, this one location. Another one is your object is exactly on the F. That one also is a virtual image. Okay, now we go to proof. Is it virtual image or not? Okay, first one, we're using first ray. Okay, remember first ray, parallel. Then we go F. This one is a first ray. Okay, the second ray we never use. We're using the third one. Okay, now we continue using the third one. This one I need to extend. So because I say virtual, this one situation must be here. So we're going to see the third ray. Okay, third ray, this part, can you see they totally cannot touch one? Sure, they are parallel and go down. Okay, if they cannot touch, that means we need to extend. We see the virtual part can touch or not. Okay, finally, you see the virtual part also cannot touch. Up and down also is a parallel. So that means this one situation means your image will appear at the infinity. Okay, they appear in the infinity, that means you cannot capture. Sure, the first one is a virtual. Okay, then infinity means the object is very far. Okay, very far means there's a very large. So this one situation means they're using as a telescope. Okay, using the telescope to see the very far planet. Okay, the star. So that means your image must be happen at the infinity part. So from here we can write about the characteristic. Okay, so the first one, virtual. Your image sure is a virtual and also very far because there's a parallel line. Parallel line means the distant object. That means the object is very far already. Okay, number 2, sure is a upright. Can you see the virtual and upright always is a partner? Okay, when you say virtual, sure, the next one should be the upright. Okay, very far object, actually there's a magnify. Okay, the last one, you need to add one more, infinity. Means now your image is captured at the infinity because you see there's a parallel line. Okay, now we can say image at the infinity. This one is an extra characteristic for this situation. So next time when you just see the situation is object exactly on the F, you need to add one more. That's an infinity. Okay, so the characteristic still VUM, virtual, upright, magnify. Same just now. Okay, then we now need to move the object after the F. When the object just move after the F, now you can see the situation no more virtual. That means that all will become real image. Real image means they can capture on the screen. So if real image later, you can see your image will appear at the part 3. Okay, this one part 1. Part 1 just got 2 situations. It's the first one, U less than F. Another one is U equal than F. Okay, now I need to move object far away a little bit. Okay, then we see what happened. Okay, the setup is almost the same. Still using convex, but now they say object O between F and 2F. Okay, this one is an object. F, this one 2F. That means there's a exactly between. Okay, you want this part also can, this part also can. Important you are between. Okay, now we write the information U less than 2F more than F. Okay, we're still using first and third. Okay, we try number 1, first ray. Parallel first, then after that go to find F. Okay, then we continue because we no need to extend. Because we know this one is a real image. We go to prove is it real or not. Okay, we're using third ray. Okay, so when you see the third ray just draw already, blue and green they can overlap each other. Okay, at the part 3. So that means we no need to extend already. Okay, extend you also cannot touch one. So we just lock it. Now your image is located here. Okay, how to draw the image again? I repeat again, this one is a horizontal line. So when you draw the arrow, you must start from the horizontal line, then you draw. Is it? So from here, now I draw my image. That means from the horizontal line. Okay, so I draw first. This one is a image. So your image, you start from the horizontal, then you go downwards. So this one is a real image, so we no need to draw the dotted line. There's a full line. Okay, then we introduce. This one is a object distance. Okay, then where's the image distance? We must start from the center, go to image. So this one we call image distance. Okay, now we do the comparison. Image distance longer than object distance. Okay, then the second one is characteristic for the image. So we compare with the object. Is it still virtual or not? So your answer sure is no more virtual. Okay, they just happen at the part 3. So we call it there's a real. Okay, then we go and see the object and image. Is it still upright? The answer is no. Now already is inverted. Okay, you see the object there, the head at the top, is it? But now you see the image, the head is at the bottom. So real and inverted is a one pair of the couple. They must together one. Just now is a virtual and upright. Now is a real and inverted. Okay, last one we compare the size. The size is become bigger compared to the object. So we still write it as a magnify. Okay, so real, inverted, magnify. So the short form should be RIM. That's a rim. Okay, image distance, V more than 2F means the image distance already over the 2F. Suppose the 2F is here. This one is a 2F. That means the image is beyond the 2F, behind the 2F. Okay, this one is image distance. Okay, then the next one, I need to move the object again. Go to 2F. So you can see the procedure is I just move the object distance only. Let the object move behind and behind. Then we see what happened for the image. Okay, then we continue the next one. Okay, next one also setup is the same. But this one situation, the object exactly on 2F. So you write U equal to F. So this one situation still real. Because I told you already, when the object just after the F, all situation is a real. Okay, then you can guess already. When real, that means the partner is a inverted. So we're still using number 1 and also number 3, the ray to complete the diagram. So first ray parallel, then continue go to find F. Okay, third ray we from the object go to center. Okay, so you can find it across already. So this one situation you must more specific when you draw because your image now is exactly 2F. Okay, if you draw they cannot touch to 2F, maybe the line got a little bit inclined or not in the point. So better you go to adjust. Okay, adjust until there's exactly below the 2F. So from here we find it. Object 2F, image also 2F. So I need to add one of the info. Object distance same like the image distance. Okay, now we're going to draw the image first. Okay, so this one is an image. there's a full line because there's a real. Okay, so this one is the image distance. Then this one is the object distance. Both should be the same. Okay, let's see the characteristic. Real, inverted. Okay, now we don't have any magnify. There's the same size. So from here, the short form is a RIS. That's a RIS. Okay, the image distance V equal to F. Exactly the 2F. Image at the 2 focal point. Okay, so this one is the image distance information. Okay, then the next one, I still want to move my object further again. Then we see what happened for the image. Okay, then the situation now is the object beyond 2F. So now your object, you move behind the 2F already. So I can say U bigger than 2 focal length. Okay, we still the same. First ray. Then continue. Third ray. Now you can find it. This one is a cross part. Okay, where is the 2F? 2F actually is a 1, 2, 3, 4, 4 boxes. 1, 2, 3, 4. This one suppose is a 2F. Okay, but you can see my image already is in front the 2F. Okay, shorter than 2F. Okay, so from here, I write the characteristic first. Okay, this one image distance. This one is the object distance. Can you see the object distance already is longer? But the image distance is shorter. Just now is same size. Now object distance longer than image distance. Okay, characteristic. Real, inverted. Okay, now it's diminished. That means we compare object and image. The image becomes smaller. Okay, so the short form should be RID. Okay, D is a diminish. So image distance, where's the image? Image now is located between F and 2F. Okay, this one is the image distance. You also can say now the image distance is shorter than the object distance. So this one is a situation when the U, that means when the object already behind the 2F. So actually the conclusion we can make, when the object is go further, far away from the lens, you can see your image will closer with the lens. Okay, after that become smaller. Okay, they become smaller. Then we go to the last one. Okay, the last one is now the object at the infinity. Very far already. So from the infinity means we cannot using first ray because we cannot capture the image. So for this one situation, we got a little bit special. We're using number 2 and number 3. Second ray and also third ray. Okay, we start with second ray. Second ray is go to F first. Okay, we draw the line. Okay, go to F first. After that, parallel. This one is a second ray. Okay, now you need to draw the third ray. The third ray must be parallel with the second ray because your object is a far distant. Far distant must be parallel line. So I draw the third ray, straightforward pass to center, then cross. Okay, so you can find it when starting they are parallel, after that cross. Okay, one more thing to tell you, when you cross, okay, for this one situation, when U equal infinity, your image must be exactly located at the F. Okay, so this one we need to adjust. Right? Can you see the green and also the blue a little bit far away from the F? Actually, there's exactly below the F. So we draw the image, okay, exactly here. So this one is a characteristic. When you find the object distance infinity, finally where's your image located, they must add the focal point. I show you the image distance. Object distance we can also too far already. Okay, now it's a real, inverted, also diminished because this one object is very large. Okay, finally you get the image become diminished. Okay, after that, this one is V equal F, far away object. So your image must be located exactly the F. V equal F. So image at the focal point. Okay, remember this one situation. Okay, so after that, we need to continue the next one. That means the formation image by the concave lens. Just now it's all convex. Okay, now we go to concave. Okay, concave, can you see the center become thinner? So this one is a concave, but we're still using the center whole straight line, the vertical center line. Draw the situation for the object. Okay, different situation. So now the object is between F and also the optical center. Means the object now is in front the F. So we see what happened. Okay, you also need to memorize again how to draw the ray from the concave. Because concave and convex is a different the line direction. So the first one, we're still using first and third. Okay, first ray parallel. Okay, then this one we cannot straight forward go to F. They need to go the behind F. So they go to behind F using dotted line. Remember, this part is a part 1. This part is a part 3. So part 1 is a virtual. So you're using dotted line. Okay, after that you make the line diverging. Make it become longer. So this one we call first ray. Okay, third ray, whole straight line go to center. So just like this. So where it cross, they cross here. So find it, the cross just in front the object. Okay, so we go to draw. This one is a part 1. So your image must be virtual. So virtual, we draw dotted line. So this one is your image. Image distance, the shorter one. Object distance is from this one object until the lens. So this one called object distance. This one is the image distance. So from here we see very clear, object distance longer than image distance. So characteristic, virtual. Virtual partner must be upright, but there's a diminish. We compare object and image. The image becomes smaller. So from here the short form, VUD. Virtual, upright, diminish. Now we go to the second one. We move the object again. We see what happened. Okay, now the object I move further until beyond the 2F. Go behind already. Okay, we're still using the first. Then we come back to F first. Then make it become longer. Okay, then we go third ray. Okay, can you see the overlap still at this location? That means just now it's in front a little bit, is it? Now it's behind a little bit. Still in the range of the F. Okay, we draw the image first. Must start from the horizontal, then you start to draw. So that means your image must be up. Okay, the image up, dotted line, because this one too small already. Cannot draw the dotted line. Suppose it's a dotted line because this one is a part 1, virtual part. Okay, now we go to label. This one is a image distance. Image distance. Then this one is the object distance. Okay, characteristic. Virtual, upright, diminish. Is it same like just now? Actually, that's the same. So that means for the concave lenses, we no need to memorize so many characteristics, same like the convex. They just got one type only. This one is all characteristic. So that means don't care your object move this location, or last location. Your characteristic for the image always same. That means the characteristic for the image is always located here. They cannot over the F. So you no need to memorize so much. You just go to memorize virtual together with the upright, and the last one is a diminish. For the concave, your result must be smaller, diminish. Okay, then we're going to see the short form. The short form is a VUD, virtual, upright, diminish. Still the same. Now your image distance always less than F. Okay, after we see all the lenses, how to draw the ray diagram. Okay, now we need to find out linear magnification. That means you need to find out your image actually the big how many times from the object. So from here, when we need to count the linear magnification, the symbol is a M. Okay, equal to we put the image at the top. Okay, image height over object height. So from here, if follow this one diagram must be HI over the HO. Then you can find your magnification is how many. Okay, beside using just now formula, we still can find the linear magnification by using the distance. Okay, image distance over object distance. So remember, always using the image over the object. Just now it's the image height over object height. Now it's image distance over object distance. Okay. Okay, now we're going to see the result after we get the answer from the magnification by using two different formula. One is V over U, another one is a HI over HO. Okay, so when you get the M is a 1, okay, we put modulus, means the magnification cannot get negative. Okay, if you get 1, means your image and object same size. Okay, number 2, if you get your answer magnification is more than 1, means you are magnified. Your image become larger. Okay, when you get the M is less than 1, means 0 point something. No negative, just 0 point something, means your image is a smaller image, diminish. So from here, for the magnification, we don't have any unit, just the value only. So you must remember the formula, how to find the magnification. Okay, then we go to the last part. There's a formative practice from your textbook, 6.3. Okay, let's see the question. 6.35, they show about the image that's seen through the convex lens. Okay, with the focal length, there's a 10 cm. Okay, now we observe the diagram. Okay, can you see the image become larger? Okay, larger already. So from here, this one, they're using example as like the magnifying glass. Okay, make the image become larger. So what are the characteristics from the image? So the characteristic is a magnify. So we can see there's a magnify, is it? Okay, number 2, you need to draw the diagram to show how the image in the figure is formed. Okay, after you mention characteristic, you need to draw. Okay, draw same like just now the ray diagram. And the last one, you need to suggest the suitable position of the place of the object to produce an inverted image. This one is upright, is it? Okay, now we go to answer one by one. Okay, first one, virtual, upright, magnify. This one is a characteristic for the image. Okay, how I know there's a virtual? Actually, I don't know. I just know there's an upright and magnify. So you go to find out when there's an upright and also there's a magnify. Upright partner is who? The answer is virtual. So that means this one situation, when I just using the paper to close it, actually you cannot see anything. Okay, number 2, I need to draw the diagram. Draw diagram, that means you set up. Okay, this one is my setup. Okay, my situation, you need to draw the diagram for this one, virtual, upright, and magnify. Your object must in front the F. Say U less than F. So now I go to draw first ray, go to F, then third ray. Okay, this one situation, you need to make it become longer, remember, because you want to get the virtual image. Okay, then you cross. So your image must be bigger and also virtual. Then you draw dotted line. Okay, so this one is the diagram you need to draw. Okay, so this one is the answer for question 2. Okay, image. Now we go to answer number 3. Suggest a suitable position to place the object to produce an inverted image. You want to produce an inverted image, remember your object must move after the F. Okay, if in front the F means the focal point, you should get virtual. Now I want get inverted and real. So that means your object distance must move after the F. Okay, so they say object must located the distance more than 10 cm. That means more than F, because the question said 10 cm already. So must more than 10 cm, then you can get the characteristic is a real, okay, and also inverted. Okay, so this was the answer for formative 6.3. So hopefully you understand this topic. Thank you.